Alright, so maxima minima. In questions relating to maxima minima, we will be provided with a geometrical figure with two unknowns, and we will be given its perimeter, area, or volume. The requirement would be to express one of these two variables in terms of the other. That is, if we have x and y, we can be asked to express x in terms of y. That would be x is equal to y something, or let's say y square plus y, something random. Alright, and then we could further be asked to find the area, volume, or perimeter in terms of one variable. And finally, the question may even ask us to find the stationary values of the unknown variables. So if your question asks either of these things, so the question falls under the category of maxima minima. We'll take two examples. Let's say we are given a rectangle with dimensions 8x by 2x, and we are given that its perimeter is 72 centimeters. So the first part is express h in terms of x. So the formula for the perimeter of a rectangular block is 4 length, 4 times the height, and 4 times the breadth. Thus, we'd have something like 4 times 2x, 4 times the height, and the breadth x. Simplifying this would give us 12x plus 4h. The question gave us the perimeter, which was 72, and thus we can express h in terms of x. So 12 goes there, and we will be left with something like this. Taking 4 common, we'd have 18 minus 3x, and the 4's cancel out. Thus, this is our answer. So h has been expressed in terms of x. Now, we have been asked to find the volume in terms of x. So the formula for volume was length into breadth into height. So we have, by what we are given, the dimensions, it would be something like 2x into x into h. Now realize that first part made the work easier. We already expressed h in terms of x. Now simply substitute h by that. So we have 2x square after we multiply this, and substitute the equivalent of h. And finally, we'll be left with something like 36x square minus 6x cubed. Kudos. Then, given that the volume varies, find the stationary values of x, h, and volume. Alright. So this is where calculus comes in. So we need to differentiate the expression of volume which we obtain. So we were given this. This is what we found. Rather, we'll move this here, and we'll differentiate this expression of volume. So we'll turn out to have 72x minus 6 into 3, 18x squared. And we'll equate this to 0. Solving this would give us this expression. One of the x's cancels out and the value of x turns out to be 4 centimeters. Since we now have the value of x as 4, we can go on to find the height, which we expressed as 18 minus 3x. From the first part, we know the value of x, thus height turns out to be 6 centimeters. Finally, we need to find the value of volume, which turns out to be, after substituting the value of x in this expression, 4 square minus 6, 4 cube, and the volume turns out to be 192 centimeter cube. So we found x, h, and volume. Moving on to the last and final part of this question. The topic is called maxima minima, which indicates maximum or minimum. So we are asked to determine whether this value of volume is maximum or minimum. This volume. I missed volume. Please correct that. So in order to determine whether it's maximum or minimum, we need to find the double derivative. This was our equation of volume, and we can continue finding the double derivative. dy by dx was this. We'll copy this too, and then simply just make a margin. So the double derivative turns out to be 72 minus 36x. Since the value of x which we found was 4, we'll substitute that, and we'll turn out to have a minus 72. Since minus 72 is negative, thus the volume is maximum. Since minus 72 is less than 0. Moving on, our second question. A solid cuboid has a square base area of length x. So we have a cube, x by x by x. Given that the height is y centimeters, given that the height is y centimeters and the volume is 27 centimeter cube, express y in terms of x. Since we are given the volume, first of all write down the formula to calculate the volume of a solid cuboid. Length, breadth into height, or simply base area into height. Since the base area is a square, thus it's x into x into y, and the volume was 27. Simplifying this would give us the expression for y, which is 27 over x squared. Then we're asked to show that the total surface area of the cuboid is this. So the formula would be, since we need to consider all faces, so it would be surface area is equals to 2 into x plus 2 into x into y. Notice that it's 2 into all possible combinations. You must know the formula by now. And thus, after simplifying, I'll have 2x squared plus 4xy. Now notice that this expression is in terms of x. So we need to substitute y by its equivalent in terms of x. So 2x squared plus 4x, and y is substituted by its equivalent, 27 over x squared. Simplifying this further would make us end up with, so this cancels out with this, and 4 into 27 is 108 over x plus 2x squared. So this is the surface area, and we show that as required. Moving on, if x can vary, find the stationary value of the surface area and find whether it is minimum or maximum. So this was the expression of surface area given to us. We can rewrite this as 2x squared plus 108 x minus 1. So differentiating it becomes easier. You make a margin. Do make a margin in your exam paper too. It improves readability. So dA over dx is equals to 4x minus 108 over x squared. This is the double differential, and we'll equate this to 0 since the gradient at the stationary value is 0. Moving on, 4x is equals to 108 over x squared if this goes to that side. We'll have x cubed is equals to 108 over 4, and x cubed is equals to 27. 27 cubed turns out to be 3. Then we still have to determine whether it's minimum or maximum. We found the value of x and we did make progress, but the final step is still left. That is the double derivative. So d square over dx square. The double derivative would be 4 minus, or rather plus, since it's minus 108 into minus 2, 216 over x cubed. Substituting the value of x, which we found 3, this would give us 4 plus 8, and the double derivative turns out to be 12. Since 12 is a positive number greater than 0, thus this value of surface area is minimum. However, things don't end here, since we still have to find a stationary value of a and whether it's minimum or maximum. So we did determine its minimum. So this is one of our answers, but we still have to determine the stationary value of a. So the expression was for surface area was something like this. A is equals to 2x squared plus 108 over x. Substituting this stationary value of x, the stationary value of the surface area would turn out to be something like this: 18 plus 36, and the surface area turns out to be 54 centimeter square, and this is minimum. So this is your answer. And here we're done with maximum minimum. You understood what it is, what the questions may ask you to find or do, and you did two comprehensive examples, exam style examples. And this is where we wrap up.